Hey everyone, welcome back to another video about managing your SQLite databases using the Room Persistence Library. In today's video, we're going to take a deep dive into database migrations using Room. Now if you've never worked with database migrations, that's fine, that's what we're going to learn today, but I do recommend understanding the basics of the Room library. So if you've never used it, check a link in the description for the Getting Started docs. A database migration is when you need to take your application and move from one version of your database to another. So with that in mind, we're going to start this video with a sample app that's already built, that already has a database on the device, walk through it, and then understand how to move from that version to something different. So let's dive into the code. So as I just mentioned, for this project, we're going to start with a sample app that's already started. And it's just going to have a database with one entity in it. And that's what you see on screen right now. We have a student entity with a primary key of the student ID, which is a long, the first name and last name, which are both strings. If we go into our student DAO, we have two methods. One to insert a student and get the ID back, and one to fetch all of the students that are in our database. Then of course, we have our database class. Now we'll notice at the top here, where we have the @database annotation, that defines everything we have so far. We have our list of entities, which is just student, and our database version, which right now is 1. And then below this, we have a helper method to create the database, and you'll notice that for this sample, I've set allow main thread queries. I don't recommend doing this in production. All database operations should be on a background thread, but we've done that here just to help make the concepts we're talking about a little easier to understand. And then in addition, we have our main activity, and all this does is create an instance of our database and try to insert a student. Now the reason I do this is to make sure that we can run the app and see our database created and modified, and we have no crashes. So everything looks great so far. Now let's try to do something that is going to be very common in the real world. We're going to have to change something about our data. So let's go into our student entity, and we're going to give it a new property. Let's say we want to start storing the student's age, and their age starts at 0, by default. When we run this, we're actually going to see that Android Studio is going to crash. Our application doesn't work. And if we look at the reasoning for that, we'll see we have an illegal state exception. Room cannot verify the data integrity. Looks like you've changed schema, but forgot to update the version number. So Room gives us a very helpful error message here. We can just go into our database class and update the version number, right? Well, when we run this version, we're actually going to see another crash. And this time, we'll get another illegal state exception saying a migration from 1 to 2 was required, but not found. And then some information on how to specify the necessary migration path. And that's what we're going to look at next. So just to clarify this problem, when the user installs the first version of our app, they're going to have a certain database schema that's created on their Android device. And then when we change that, and they try to install a new version of our application, SQLite isn't going to understand how to move from that first version to the second version. And we really have two broad categories of ways to handle this problem. The first one is destructive migrations. What this will do is say, if I don't care about the data that was already on the device, when the user upgrades, let's just delete the database that's already there and create a new one with the schema we want. In some scenarios, this might be fine, but in other cases, you might not want to lose the user's data that was already there. In which case, we need to help SQLite understand how to migrate from one version to another so that users can gracefully update the app without losing any stored data. Let's start by looking at the first one and understanding our options for destructive migrations. So here we are back in our student database class. Down below, we have our create database method, which creates a Room database builder. And this is where we define all of the migrations that need to be supported. The first of the destructive migrations that we're going to look at is just the method Fallback to destructive migration. And what this will do is when you install the app and Room doesn't recognize how to migrate from one version to another, it's just going to get rid of everything and start a new app from scratch. Now, if you want something like this, but you don't want to support it in every single scenario, we can actually go with the more granular Fallback to Destructive Migrations From method. This will allow you to specify any starting database version that you want to just use the destructive migrations. So in this case, we have versions 1, versions 2, versions 3. If we're upgrading from any of those, let's just destroy everything and start over. But if we're migrating from, say, 4 to 5, then I want to make sure my database handles that version directly. And another one we can look at is the Fallback to Destructive Migration on Downgrade method. What this will do is basically check if we're moving from some higher version to a lower version. Now, it's rare that you would do this to your users, but this can happen very often in development when we have a developer who's working on a new database schema and we go to test their branch and then we move back to our branch, which is still using the old database. When I run that on my test device, I'm going to have a database downgrade, and that's often going to create a crash. So something like this, Fallback to Destructive Migration on Downgrade, can actually be quite helpful inside of a development scenario. So as developers, the destructive migration approach that we just looked at might feel nice, because each one was just a one-line change to be able to move from one version to another. And in some scenarios, this is fine. You have to talk about it with your team to understand if destructive migrations are okay. But if you really want to provide a good user experience and make sure you're saving data when they migrate from version 1 to version 2, we're going to have to do a little more setup to tell Room how to handle that migration, and then how we can also test those migrations ourselves so that we can ship this app with confidence. So let's dive into that project setup first. Now, before we dive into the code for creating our database migrations, I thought it would be helpful to talk about the project setup that we need to do before we can write or test our migrations. Now, testing our migrations is actually important. We want to write some sort of unit test that can verify we move from one database version to another. And in order to do that, we're going to need to tell Android to create a database schema for each database version that we create. And then having those schema files, our unit test will be able to know how to create a database at version 1 and move to a database at version 2. So to do that, we're going to go into our buildback Gradle file, and inside our project, we're going to add these Java compile options, annotation processor options, and define where we want our room schema location to be. And this is going to be inside our project directory /schemas folder. This is something that we define ourselves. We only have to do this once, and you can actually copy this code directly from the Room documentation. Once we build our project after doing that, we'll see that we can find a file called 1.json. And the 1 is because we were on database version 1 when we did this. It gives us information like how to create the tables, information about each of those table columns, what's their name, are they nullable, non-nullable, all that fun stuff. We might actually revisit these later. After that, we need to go and define the source sets for our project. So we've created this directory that has all of our database schemas inside of it, but our Android test that we write won't know how to reference those schema files right away. So we need to do some more Gradle configuration and tell it to use those schema directories inside of its assets. And then one thing to make sure we include is the room testing artifact. Make sure we use the Android test implementation and specify this library so that we can get some test helpers that Room provides to us. Now that we have all of the project setup required, we can go back into our application code and actually write the migration from version 1 to version 2. Remember in our example earlier, we had a student entity, and we gave it a new property called age. And then inside our database, we updated the version to version number 2. The next thing we need to do is go into our database builder and tell it what migration paths are supported. Now, before we can tell it that, we actually need to create our own migration. Now we're going to create a migration here, and we're going to call it migration_1_2. And this naming convention, you can use whatever you like, but this naming convention is, I have a migration, it's going from some start version, in this case 1, to some end version, in this case 2. This needs to implement or extend from the abstract class migration. And then we're going to override the Migrate method, which takes in a support SQLite database. I also forgot a step here. Our migration needs to specify the start and end version. So once again, that's 1 and 2. Another thing that can be really helpful is to go ahead and put some Java docs on top of your migrations. A future developer could come in and look at the migrate method to understand what's happening, but it can be really helpful at a high level to understand why I was migrating from one version to another and what's different. In this case, we've introduced the age property. So now we get to the fun stuff, the migrate method. Now, inside this method, we actually need to perform some manual SQL statements to tell the database how to support what change we just made. So we're going to use the exec SQL method and then write in the statement that we want to run. In this case, we're going to alter table student. Now the table name is student because that's also the name of the class in the other file. We're going to add a new column called age. It's an integer, it's not null, and we're going to specify a default, which is 0. Now, if this were a nullable column, we wouldn't have to specify a default, but because it's not null, we need a default so Room knows what value to give to all of our previous rows that already exist. So now that we've created this, let's go back into our database builder, and we can add a new call to add migrations, and we're going to pass in migration 1 to 2. Now this takes in a var arg of migrations because you can have more than one for different database versions. So once we've done this, let's actually go ahead and run our application again, and all we're going to do is make sure that the app doesn't crash like we saw it did before. If we run this, everything looks good. Our application was able to migrate from version 1 to version 2 without a problem. The next thing we're going to talk about is actually writing tests for these migrations. Now, a lot of times as developers, unit tests feel really burdensome, but when it comes to database migrations, writing unit tests will actually save you a lot of time. Think briefly about the manual process involved. You have to get a version of your app on the old database, run it on your test device, then switch to a branch with the new database, run that on your test device, and if it doesn't work, you have to start that whole process all over again. And that only works for 2 versions, not however many different migrations you might have. So it's really helpful to write some of our own code that can test a migration from any given version to another version. So let's talk about how that works. So here we are, back inside of our student database class, and we've just written a migration from version 1 to version 2, and now we want to write a test to make sure that that migration works the way we expect it to. So let's go into this other class that we've created called Student Database Migrations Test. Now just briefly, note that this uses the Android JUnit forerunner, and it lives inside of our Android test directory. The reason for that is because we're writing a SQLite database test, so we need to use an actual SQLite database that's on an Android device or emulator. We can't write this as a regular JVM unit test. Some initial setup we have to write in our test is to create a reference to the database that we'll be manipulating. Here, we're going to use a support SQLite database because that's what the Room test helpers give us. We're not going to use our own student database class. Next, we need to use a JUnit rule for a migration test helper. Now this came from the Room documentation. This is something I'm not super familiar with, but this JUnit rule provides us with some helper methods that allow us to create a database at one version and migrate it to another version. So inside this migration test helper, we're going to tell it what instrumentation we're running our test under. We'll give it a name for the database. Here we use our student database class, canonical name. And then we also give it a framework SQLite Open Helper factory. And again, all of this came right from the room migration documentation. Once we've done that, we're going to start our test, and we'll call this test Migrate 1 to 2, because those are the versions we're working with. The first thing we need to do is create a database at our starting version. So we can call migration test helper.create database, give it a database name, what version we want to start at. And in this case, we're also going to call the .apply method so we can do some manipulation of the database before we migrate. And the reason for that is because we want to make sure we have some data that we can migrate to a new version and make sure that same data is still there. So here we're going to write some more manual SQL to insert a test student into the database. Here I'll insert one with my name, and then I'll close the database. Now the reason we need to use manual SQL here is because all of our room DAOs are working with the latest database schema. But version 1 is not our latest database, so we need to write that write those SQL statements ourselves. Next, we're going to update our database by using this method called run migrations and validate. We're going to give that again our database name, what database version we're moving to, a Boolean parameter for validating our database tables, and then any migrations that should be run. Now once we've done this, we are able to validate our schema in Room, and we know that we were able to migrate from version 1 to version 2, but I think we can take this test a step further and make sure that the data that is now in the database matches what we had before. So as I mentioned when we started writing this test, we had to write some manual SQL because the room database access objects weren't supporting the old database versions. But now that we've migrated to what our latest version is, we can go ahead and create a reference to the database directly. So let's go ahead and use the room database builder. We'll give it our instrumentation registry's target context. We want to create one for our student database, and then we need to give it the same database name that we've been using, test-database. Now it's probably a good practice to move this into a constant, so I recommend doing that in your own projects. We'll again use allow main thread queries so we can focus on the migration concepts and not worry about threading, and then we'll build the database. Once we've done this, we want to query this database and make sure the information there matches what we're expecting. So let's start by requesting all of the students and just getting the first student, because there should only be one row. And once we have that, I want to validate that the data that was there before is still there, and any new fields that we've added, like the age property, have our default value. So to do that, we're just going to assert that the student's first name is Adam, and we're going to assert that the age is our default value of 0. Now if you want to be more thorough, you could check every column in this table, but really just by doing these two things, we've verified that we didn't lose any data, and all the new fields got their proper default value. While every database migration is going to be slightly different, with today's example, we've built a recipe for handling database migrations that's going to apply no matter what the change to your schema is. You need to create a database migration from one version to another, write the manual SQL to handle that migration, and then we learned how to write a unit test to make sure that migration worked, and that followed a similar recipe. We're going to create a database at our starting version, insert some initial data, run that migration to our next version, and then validate the data after that migration is what we expect it to be. I hope you found today's video helpful, and I know there's a lot more to learn about migrations, so I'd like to show you a few resources I've made to help you understand how to do this for other types of database changes. This is a GitHub project I've created for mastering room migrations. It's an Android application with all of the code you saw today and some additional examples of room database migrations. I wanted this to be a helpful resource for you to learn how to handle different types of migrations, because while we've built a standard recipe for handling them, We have different migrations in the real world, adding a field to an existing table, removing a field from an existing table, changing the data type of a field, and it can be very difficult to remember the manual SQL required since we don't write SQL every day as Android developers. So there's some notes in here about making sure you understand how your room entity table and column names map to the underlying database. And then for each type of migration, there's a little cheat sheet of SQL statements you need to know and perhaps additional information that are helpful for a migration. Like in this example, for removing a field from an existing table. SQLite actually doesn't support removing a field from a table. So we have to follow this 4-step process of creating a backup table with the schema we want, copying everything from our existing table into the new one, deleting the old table, and then renaming our table. And if that's a lot, use this cheat sheet, and each one also has a GitHub pull request for each individual migration, so you can look at that in an isolated format to help you understand what to do and how to test that specific migration. I really hope you found today's video helpful and that you learned a lot about database migrations. I hope they aren't as intimidating as they may have seemed before this video. I hope you find all of the resources helpful as well. You'll find a link to each one in the description. Since the Mastering Room Migrations project is open source on GitHub, if you've experienced a type of migration that's not in the cheat sheet, feel free to contribute a solution yourself or open a GitHub issue and I'll see if I can help you out. If you have any questions about migrations or other topics of SQLite database management that you want to learn, please let me know in the comments. Thank you so much.